Teemu comes from the research unit of medical imaging, physics and technology, and actually the name has most recently changed, but apologize that we have used these previous names.
Yes.
Okay. You are warmly welcome, Teemu. The scene is yours.
Yeah, as said, I come from the research unit of health sciences and technology. Nowadays, that's the name. I have also researchers in my former unit where I was working in optoelectronics measurement techniques unit. So my background is more on biomedical engineering, health technology in general, instrumentation, sensing, and creating applications around wearable techniques nowadays. And my presentation will reflect that mostly. So how 6G can in future be utilized in such. So shortly about the research background at first, some more general examples, what could be already in near future utilizing 6G, and then I tell about our ongoing projects and how I'm really excited to utilize wireless technologies, what we already aim to jointly do with the CVC guys. So I must say in University of Oulu, that's the best place to make research on biomedical engineering. And the reason for that is that there's so nice close collaboration with the hospital, University Hospital, Biocenter Oulu, and Faculty of Medicine and Information Technology and Electrical Engineering, also VTT. We are all jointly collaborating and doing research for very interesting topics. So what we have in Oulu is starting from the very principles of sensing, studying such technologies, simulation models, then phantom models, making devices. In Biocenter, we can also do joint preclinical research, but then very importantly also in the hospital. We don't need to play with each other researchers making measurements, but we can, when having ethical permission, also collect data from real patient cases. So all of these are already possible in Oulu related to brain technology, where I'm mostly working about 15 years. But health technology started already in the 70s in Oulu, like Professor Seppo Säynäjäkangas with Polar and so on. So with Vesakivi, we have this nice neuroimaging environment where we've been developing different modalities that can be used endlessly. So I've been mostly working on our blood pressure measurements and then the optical measurements of the brain. This is one example. A long time ago we designed for the MRI environment. Why I'm telling this is that, so this is one picture how we actually do it. So we have optical fibers, but the device itself is outside the chamber. But now, since we've been working quite long already on the brain technology, now since few years, the aim is to start brain studies also outside hospital. And that is the wearable technique, and the 6G comes so in good moment also to us. So we've been discussing about, in general, wearable brain monitoring, and there is excitement. So that is interesting topic in general, also for the public. We have also quite many study cases ongoing with the hospital colleagues. So these are related to oncology, then Alzheimer's disease, but also, so I will tell about this, but also some other study cases. And I see there is lots of potential to develop diagnostic methods, models with the clinicians, so that it's ubiquitous, continuous, decentralized healthcare concepts. So this requires, of course, this wireless technology. I will tell you these shortly. Just some examples, I think these are quite well known, but still I would say it would not be possible to have these cases without reliable wireless connectivity for the healthcare devices and then to the medical doctors. All these AIs and such, of course, support these. So one is definitely remote area sensing, and it's also related to this mega trend of decentralized healthcare. Person doesn't need to be necessarily close to the hospital, but still can be controlled when having disease. This immediate health diagnostic is, of course, of high interest and importance, and we are also working on this topic. So in ambulance, that there could be immediate connection to the hospital site and already before the patient is arriving to hospital, there is some knowledge what is the reason for the emergency. This is also one example what we are developing, smart card health sensing. This is also a nice application that could be in future utilized for data collection like cohorts. Many people stay quite long time inside car when driving, and the location collecting data inside car is actually quite nice because it's controlled. You always sit in the same position and we know what is the environment. So that I see would be really nice place just to collect data, but of course for diagnostics, if there's disease, would be important. Home monitoring, so in our case, brain monitoring at home, that hasn't been done yet much. Most of the sensors in home, as we know, are these wristband sensors, still measuring heart rate related signals and making analysis models for that. But I'm quite confident that in 5-10 years there will be lots of applications that are directly measuring from the brain, not necessarily continuously, but anyway that is done at home and will enable new diagnostics models for brain disorders. In general, data collection outside hospital provides lots of opportunities for clinicians. As we know, most of the data now for diagnostics, it's collected when the patient is visiting hospital, and that's a normal situation. So in real world situations, there are actually still not yet data collected from patients, and the data may look quite different when it's measured in outside hospital and real world situations. For the brain, especially that is the case. Now the brain function is measured like in magnetic resonance imaging. You go inside tube and that is really for the scanning. That is really not a natural environment. All of these with 6G possibilities, I see the exciting possibilities. Okay, so then about our projects that I think we will provide, I call it next generation healthcare for the brain. So as said, we've been working about 15 years on these. So the last years we've been focusing on neurohydrodynamics. And what I mean by that is we measure the neural activity, but then brain fluids, including hemodynamics, but also cerebrospinal fluid dynamics, and in general the brain dynamics, which includes the brain pulsing. So we are not doing brain imaging, we are measuring the dynamical changes, what we can measure with the wearable sensors. All of these are linked with degenerative diseases, and that is where our focus is. There are quite important diseases related to NDD, Alzheimer's disease, Parkinson's disease. So here are some numbers, 500,000 cases for Alzheimer's disease every year. If there would be method to diagnose risk of Alzheimer's disease or early phase of it, that would be very beneficial, and that's where we are aiming. Also, lifestyle, how you sleep, such things have been shown that they may affect your brain health. And if we could measure that, for example, at home, similarly as now using these wristband sensors, that could improve our possibilities to control our brain health in everyday life. So at the moment we have this kind of prototype for brain monitoring wearable system that includes all these modalities, so hemo and water dynamics, brain pulsation, and then some other modalities, and then also blood pressure, breathing, heart rate, such things. These all are very important parameters when studying the brain related to NDD. Yeah, and before I go to these two study cases with this Glymphometer, basically, there's also this bigger vision. Of course, this is not only my vision, it has been there, but in this moment, I think with the 6G, it enables lots of possibilities here on the left. So for research, cohort data collection, that will be something that is quite something new than how it's done now. So as said, it's done in hospital. In future, we can collect cohort data in real environments, and that will open up really much more interesting diagnostic possibilities. So these in all related to the 6G flagship, I'd like to think this what we can do. Then also for the industry we can test wireless sensing techniques here in Oulu, which is not possible in many other places. And since we have this nice collaboration with hospital, then we can develop also these ubiquitous clinical pathways that is already studied with real patients. And here what we have is in radiotherapy for oncology, and then for Alzheimer's disease diagnostics. So I will tell about this now more. So we have just ended Academy of Finland project related to radiotherapy monitoring, where we have collected from the patients in real time during the actual treatment data what is actually happening when there is irradiation beam aimed to the brain. There are some studies that there are also long-term effect of radiation, but that hasn't been studied so in human. So what we aim to do is that we collect the data from the patient in the hospital, as we are doing now on weekly basis, but then also at home. And this kind of controlled treatment is in our plan. So this will in future provide for medical doctors better possibilities to control the actual treatment and make tailored treatment plans for patients. So we are collecting in the hospital quite a lot of data from blood samples, but also ex vivo tissue samples, but most importantly also from human patients. And what we can already show that there is clearly such responses that we can measure, for example, tissue oxygenation changes. There are also long-term tissue oxygenation changes, but no one knows how these are linked with the actual therapy outcomes. So this is in our aim. Very important that what we've been doing in the hospital mostly with Professor Vesa Kiviniemi and Professor Lauri Eklund, jointly related to this Alzheimer's disease, lymphatic system or brain clearance monitoring. And there I see really lots of possibilities when utilizing wireless technologies. And this set provides this cohort data collection, much bigger amount of data collection in general from patients, but also this home monitoring and monitoring in real environments. So we are developing this kind of analysis models that are based on machine learning, so different features what we can measure from the neurohydrodynamics can be utilized for building different index values or trends, and what we can already show is that there is age-dependent index values, but also disease-dependent index values. So just 2 slides, very interestingly also in Oulu there are actually one very novel therapy in development for Alzheimer's disease. I think I cannot tell about that, but this is another what maybe you have heard for focused ultrasound therapies that has been already shown that it may improve the condition of dementic patient. There we have another project where we are developing direct sensing technique also, so with light. The ultrasound modulates the light that we can utilize also then for the monitoring of the ultrasound. So hopefully we get this in all this device. But for the diagnostics, so at the moment we can distinguish Alzheimer's disease and MCI patient here quite accurately with our wearable device. The next phase is how early we can detect. If we can detect the risk of Alzheimer's disease or neurodegenerative disease already before there are no symptoms, that would be, of course, then the most interesting and useful method. So this year we are starting to collect data from patients in several countries with wearable technique. I'm hoping we can also utilize this wireless 5G, maybe in future 6G technologies, also in this data collection, because there will be hundreds of patient data measurements yearly. And only with a really big amount of data, it will be possible to develop machine learning-based methods to calculate this in index values for risk of dementia. So the idea preliminary is with this kind of index values that it shows risk of getting neurodegenerative diseases, but also the brain clearance activity on daily basis. So some preliminary results we have that it changes depending on how well you sleep or what you do in your daily activities. And the idea would be that you can affect it and reduce at least the risk of getting these brain disorders. The risk age is here between 40 and 70, so especially during these ages, it would be highly important to observe the brain health. So this we are starting also with US partners and Holland partners to collect data. So how daily activity can affect your, we call it G-index, but brain clearance activity. Hopefully in 2 or few years we can really show that what kind of activities of your daily life may change into brain clearance. Yeah, so that's about also some collaborators, our group members, but and funders I like to thank. Any questions?
Thank you, Teemu, for your fascinating talk. Meanwhile, waiting for other questions, maybe I will start. So this G index and monitoring, that is very, very interesting, and also for the field of developing brain, also children and teenagers in future. So of course you have to start from certain cohort. But I was wondering that, what is your vision for the future? That would it be possible at some point for patients to follow this G index or individuals, so just among the population, and then adapt your time schedules in real life, in everyday life, and then there would become a certain alarm that now you have to stop working with your computer or sleep more, or just using that kind of watch or small device so that the patient could follow the G index by himself.
Yes, that is exactly the aim. And so basically this G index we can measure in 5 to 10 minutes. So it doesn't mean that it has to be the whole time on your head. So ideas you measure in the evening and in the morning. But so at the moment we can distinguish these index values like disease, as said, Alzheimer and control. But then how can you affect this G index? That we don't yet know. And that exactly requires this huge amount of data. 10 years ago that would have not been possible, but now I think, especially here in Oulu with our joint forces, that will be possible and requires that volunteers with different ages and also, of course, disease-related patient groups collect this data and they can build, basically based on machine learning, index values, and hopefully in future there are specific trends that tell, for example, your condition of the brain, risk of it, and such. And I think in any way it will be more personalized index values, so there won't be any absolute values that will tell certainly you have this and that coming, but you have your own trend values, and if you follow it like several years of life, you can then act if there is some drop in the signal. So.
Yes, and especially evaluate your individual risk and really target to prevention. This is what is very important. Are there any questions in the event room? And what about among the audience? Yes, there are many questions. Maybe we will start from here.
I am a business scholar from CMS, the same university, and I got there are many sensing techniques about the brain, but this time my question is focused on liver tissue, localization, and we are searching such a technical. I think I can find some useful suggestion. You know, if a piece of liver tissue is bad and the doctor decide to cut it, before the tissue remover, we must first collapse the vessel, then cut the tissue. But the tissue is elastic, so if doctor decide to cut that one, when they use the knives and the facilities, then it's gone. So could you give me some suggestion about, is there any techniques to help doctors to locate the liver tissue? Thank you.
Yeah, thank you for the question. We have actually had a few years projects related to liver cancer. And I think, so non-invasively we cannot measure it, at least not easily. But biopsy is something that the doctors can utilize. And in our method, we had like optical biopsy needle. So the needle is measuring also the properties of the tissue while taking the biopsy. And for example, the stiffness of the tissue, that can be measured using these techniques. So the idea would be probably in surgery that they are measuring during the surgery operation, this tissue, does it look healthy or more unhealthy? If that was your question.
Thank you, Teemu, for your nice presentation. I just have a question as out of curiosity that you as an expert working in this brain-related research, that the advancement that has been developed so far does make any hope that in the near future we have some kind of brain-to-brain communications or brain-to-machine communications. That I know that there are some research done there, but my question is about the maturity level of advancement happening in the world. You as an expert, do you have any guess about the future implementations of brain-to-brain or brain-to-machine communication?
Yeah, very good comment and question. So these brain-computer interfaces, those in development, as you know, and I think possibilities are rapidly increasing how that can be utilized. So probably you can see, for example, in YouTube examples of using brain sensor that by thinking you can move, for example, robot arm, or if you have disorder, you can by thinking move robot that brings you something, or then spinal cord injury patients can move with wheelchair just by thinking. So that is already possible today, at least at some level. But then also if you measure this brain-to-brain connection, probably that will be also possible in future at some level. So you can basically communicate by thinking, having wireless connection with another person. So I think the main thing you have to learn, you teach the sensing technique for individuals, and if you think same way, the signal will look also same way that is recorded by EEG. Also this optical technique is supporting, that is also utilized. So that is possible, and there are lots of interesting applications coming.
Thank you, Teemu. Any other questions? Yes. Emma, you are welcome. I will give this microphone to you quickly.
Thank you, Teemu. Very exciting research. I've just a general comment. The headband that you are developing or are using already, I'm thinking using it for research in a closed environment is probably okay, but I'm thinking in the future, if you want people to use it in their everyday life, maybe you should start collaborating with Marimekko or Makia and start doing some nice caps so that, they would be nice to wear. Or even for your child patients, maybe do a tiara. I'm just thinking. Thank you.
Yeah, thanks. Very good comment. Yeah, definitely. So what I've been thinking is there are those helmets when you are driving with bicycle, could be integrated to such. But anyway, at least I would not like to have a sensor or headband all the time in my head. So I'm mostly thinking that you maybe at least 2 times per day you make a measurement, and that would be the evening that would tell how was your day, and then the morning measurement, how was your night, and those in general tell quite a lot about for those index values.
Thank you, Emma. Nice idea. So maybe a combination of nice caps for different turns and different for children and teenage and elderly, and then you just use it, measure for some minutes, and then you have a wireless devices how to follow it, for instance, from your watch.
Yeah, and of course
the combination of that kind of equipment.
Of course, there are always persons who, like biohackers, or who want to measure all the time. So those can use the Marimekko system.